Alright guys, so homework 1, problem 12. The displacement of a wave traveling in the positive x direction is dxt equals 3.5 centimeters sine 2.7x minus 124t, where x is in meters and t is in seconds. Question asks, what are the A, the frequency, B, wavelength, and C, speed of this wave? To start out, you start out by writing this equation, which is given in the equation sheet. It's d x of t equals a sine parentheses kx minus wt plus phi naught. And we start out the problem by writing down our givens. Our givens are just look at the equation given and the equation given via the equation sheet, and you can see that A is 3.5 centimeters, K is 2.7 radians per meter, W is 124 radians per second, and then phi naught is 0. To start, A was to find the frequency. We look at the given equations on the equation sheet, and we see that we have to use this formula right here. W equals 2 pi frequency. To get frequency by itself, you have to do some algebra, shown here, to get frequency by itself. And we know what W is, so we just plug in W over 2 pi. So it's 124 radians per second over 2 pi. Plugging in that into the calculator, you get 19.7 hertz, which is rounded up to 20 hertz. Now B was to find the wavelength. The wavelength we use this given formula, W equals 2 pi times frequency. You do some manipulation via algebra. You start out with K equals 2 pi over the wavelength. After manipulation, you end up with wavelength equals 2 pi over K. We know what K is, so we just plug that in. So we have wavelength equals 2 pi over 2.7 radians per meter, which is our K, which is given. Plugging that in, we get 2.33 meters, which we round down to 2.3 meters. Now, C was to find the speed of light of this wave. Using the given formula V equals wavelength times frequency, we have our wavelength and we have our frequency found in A and B. We plug it in, V equals 20 hertz times 2.33 meters. That would give us a final wave speed of 46 meters per second. I hope that helped you guys out, and good luck on the midterm.